Justin here. We're on a beautiful Sunday at home in the shop. We got Finn here. He's hanging out on his little bed over here. But we're gonna knock out a Sea-Dory project today. Last video we talked about upgrading the power distribution system in Calypso, my Sea-Dory 22 cruiser. We upsized the house power distribution cable. We put a new battery switch in. We also replaced the circuit breaker. And that was all to accommodate some of the kind of increased loads we put on the power system with the diesel heater and some of the lighting and stuff we've added. So today I wanted to talk about a new addition. We're going to put in a battery power monitor. And that's going to let us monitor the voltage of the batteries, how much current we're pulling from the house power system, etc. So stay tuned to watch the install of that. If you haven't done so already, if you like the videos, please like and subscribe to the channel. We'd really appreciate it if you take a minute to subscribe. And if you have any comments, please, I love reading the comments, good and bad, to help me improve the videos, or if you have any ideas for future videos, let me know. So we'll dive into this project. And so I ordered this off of Amazon. Looked pretty cool, had good reviews, pretty inexpensive, but it's the Faux Riot battery monitor system. And so this consists of a display, and actually a really nice display. I went ahead and already powered this up just to kind of make sure I liked the way that everything looked and worked before committing to installing on the boat. And the display on this is really nice. So it's got this display here. It's got a shunt resistor that is the battery monitor, so it'll measure the voltage drop across this resistor as you're pulling power through it. That's how it'll determine current draw. All right, so what are we expecting this device to monitor? So it's definitely going to tell us battery voltage. It's going to tell us current that we're drawing on the house battery system. It's got a display, so like if you look at this, just this manual, the cover page, it's got a display that shows you like battery state of charge, and it will show you if you're discharging or charging the battery. I'm not sure we're going to get that information the way I'm going to have to wire this up. This shunt resistor is only rated for 50 amps, and in order to monitor charge going into the batteries, I would have to put that shunt resistor between the big fat like 1 gauge motor cable and the battery switch. And I'm not sure that that is the best idea because I'm not sure how much current the motor is going to pull when we turn over the starter. And I also don't know how much current we might see if we see like a spike in current when the system is charging from the alternator. So I didn't really feel comfortable putting this between the main battery and the motor, especially because this is some like, cheap Amazon gadget. So I just didn't feel comfortable running all the power from the boat through this. But what we will do is we will run this to our house power panel, and then at least we can monitor the power that we're consuming from the battery, and then we'll still get real-time voltage updates to know kind of the state of charge of the battery. So we'll play around with that. Maybe there's some functionality we'll pick up on this that I'm not sure of. But anyway, this should be a pretty quick install. The hardest part's going to be cutting a hole in the dash to mount this thing. But stay tuned, and I'll show you how we're going to do this. All right, welcome aboard, Calypso. And one of the first things we need to do for this project is figure out where we're going to mount this battery monitor display. So I think it'd be nice, obviously to have it somewhere with the other instruments on the helm. There was this like wireless temperature monitor thing. It's like just some household deal that the previous owner had mounted here. Look, kind of cool, a little janky. But I'm thinking if we get rid of this little Velcro guy, I think that's going to be a nice home for this display here. We'll put it right in the middle of the gauge stack, so it'll be next to the alternator voltage sensor in between the motor trim and alternator voltage. But it just looks like a nice place to put that. So I think that's where we're going to put this. It's going to require us to cut a hole in the dash, which I'm not thrilled about, but especially because this is kind of like an oddball sized non-universal device. If it were just like one of these, whatever, maybe 1.5" diameter gauges, I'd be more comfortable drilling a hole in here just because I know I could maybe swap it out in the future with something else. But I got to thinking about it, and worst case, if I don't like this or this thing breaks in the future, all I have to do is 3D print a new bezel, and I can make a cool looking 3D printed bezel adapter that will occupy that rectangular cutout, then convert it to, round cutout or whatever it needs to for whatever I want to put there in the future. So made me feel a little bit less sketched out about drilling into the dash. The other place I thought about putting this was down here by the trim tab switches, like kind of in this area. The only problem is like the the viewing angle of the screen. The screen's super bright, and the viewing angle is like decent. It's not like you can't see the display, but the problem is that when you tilt, when you're looking down at this display, it kind of cuts off the upper portion of some of the digits. And so putting it down here you'd kind of have to bend over to see what that display is reading. So I think front and center here is going to look really good. It's got a nice bright color display, so I think that's going to look pretty good there. So going to go see if the manual has a template for this guy in order to know what size hole cutout to make. I don't think, I kind of cut through there a little bit quickly, and I don't think it has a template, so we're probably going to have to make our own template. The other thing that's going to be tricky is, like, you can see anytime you put in these like panel mount devices, the bezel or the flange on the outside of this guy is not very much wider than the body of it. And so, right, especially in these corners, you can see how tight that is. That just means we're going to have to be like really precise when we cut the hole in this dash. Otherwise, you're going to see the cutout behind this flange. So we're going to have to be really careful and make sure that whatever template we use or decide to make is not only accurate, but then once we do transfer the hole over to the dash, we got to do a really good job of making sure we don't oversize that hole, especially in the corners. Otherwise, it's going to look kind of janky. So let's head back to the garage and see if we can figure out the template situation. Okay, like I feared, flip through this manual, and while it's got some okay info, no template for the cutout of this bracket thing, or for this display. So we're gonna have to make our own. So I think what I'm gonna do is I'm gonna take this notebook I have, got some scissors. I'm just gonna basically get us a piece of paper to work with. I don't have any other paper to scavenge. All right, take this piece of paper and then figure out how to trace a template onto this guy. It lines up, and I got to be very careful not to let this move as I'm tracing the edges. Oops. Yeah, this is kind of a tricky thing to template. It's not really working. You know what? Plan B. I've got a better idea. All right, that idea didn't work. That kind of sucked, the paper template thing, or tracing this guy. So I think what I'm going to do instead is I'm going to use some calipers, and I'm just going to measure this and then transfer the measurements over to a piece of paper. Take these out, and then we're going to transfer this to the piece of paper. There's our template. So I'm going to cut this out with some scissors, and then we'll be able to tape this onto the dashboard of the boat and transfer this pattern over to the dash. All right, we're back inside here. Step number one is I taped off the area that we're going to put the new gauge, make the cutout. So I put masking tape on the dash, and I made it so it's, you know, considerably a little wider than our template. That's just going to help us kind of make a cleaner cut whenever we start to saw through this fiberglass and gel coat, and it's also going to give us a surface that we can kind of draw on easily when we transfer our template over to the dash. One thing to note, I've intentionally made sure that the upper portion of this tape does not exceed the top of these flanges or these bezels on the gauges. The reason I did that is because when you come back here, like the most critical step, I've learned this the hard way numerous times, before you cut into anything, always make sure you know what's going on behind it. I don't know if you can see, but there's about a 1/4 inch of space between the kind of the ceiling here and where these gauges sit. And what we don't want to do is we want to make sure that when we cut through this, we're not like cutting into the more horizontal ceiling surface. We want to make sure that our cut is well below this. So, critical step. So, now that we got our tape in place, we are going to transfer our template onto this masked off region here. All right, we've transferred, kind of sketched the template onto our masking tape, and it's time for the scary part. We're gonna start cutting holes. So, fingers crossed. Here goes nothing. All right, back in the shop, we're gonna grab some tools to make these cuts. So, first thing we need, grab a drill. We're gonna use that to drill some pilot holes into the fiberglass. And then we're going to grab a jigsaw here. We're we're going to use that to actually cut out the outline. All right, we got our drill. Grab some bits. I'm just going to grab this little it's like a 1/4 inch 9/32 pilot bit and 13/16 spade bit. I've got an idea with this one, so we may be able to measure or double check our templating. I'll show you what I'm thinking. So I had to pull the steering wheel off the boat. No big deal. Just a big 15/16 socket to pull that sucker off. But I had to pull this off because I realized I couldn't get, the jigsaw or the drill or anything in this area with the steering wheel in the way. Pro tip, before you drill into gel coat or fiberglass, it's always a good idea to start the drill in reverse before you proceed in forward. That'll help you prevent cracking the gel coat. Not really going to matter in this case because we're about to saw out any of these pilot holes we drill, but just in the future, good tip for preventing tearing up your gel coat. Okay, I've had a little stroke of genius here. The reason I grabbed that spade bit was because I was going to try and make these cutouts that match up with the holes for the wires and this stud. Reason being is now I can put this device right up against our template and then trace it in place just to make sure we've got like super accurate marks. It's always better, if you can, to template something like directly off the part and not template it onto a template and then template that template onto your cutting surface. That just minimizes kind of the room for error doing it this way. So now that I've got clearance for the holes in the cable, or the bolt in the cable, I'm going to go ahead and trace around the outside of this thing while it's in place to make sure I've got the most accurate template possible before we break out the jigsaw. All right, we've got it traced out. Going to grab the jigsaw and we are going to cut this sucker out. I'm going to make sure I aim inside of the lines. Not only is that the most conservative way to go about this, but I know that when I put this gauge over top of this tracing, I can see the line. So I know I want to go just inside of it. We can always remove material later. It's going to be a lot more difficult to add it back. So especially with that tiny little bezel we talked about, it's going to be really important to nail this. All right, here goes nothing. I better put the camera down before I start doing this. All right, a couple more things I realized. Wear a mask before you start cutting. Also, I've added some tape over my instruments and over any gel coat I want to cover up, just because I don't want the base of my jigsaw to like scratch any of these up. So, better safe than sorry. Masking tape, cover everything up that can be scratched. All right, another little change of plans here. I was having a hard time cutting the corner and making these nice round corners with the jigsaw. So I just used a drill bit that matched the edge radius of the sensor thing we're putting in here. And I drilled out each corner carefully right up against the edge of the template so we get a nice round radius. Then I just have to kind of connect the dots with the jigsaw. So this should be a little easier. Alright, I was trying to be as careful as possible, but I freaking had the saw kick back and smacked the gel coat right there. So, she's not going to be perfect. Every time I look at this thing, I know that's going to tick me off. Maybe we can fill it and paint it or something in the future, but almost got out of the woods here clean. Alright guys, if I got mask face right now. We have the thing freaking fitted finally. You can see I dinged the gel coat there. There's a tiny little crack there. I had to overshoot the hole size just slightly because it was a little crooked. Moral of the story, I freaking hate drilling cutouts for rectangular objects. It's so hard to get them perfect. And I know these little nicks are going to drive me nuts. So I've got, we're going to cheat a little bit. And we're going to bust out the 3D printer and build an extended bezel for this thing. So let's hop on the computer, draw something up, and print out a little bezel that'll cover up some of these imperfections and hide our sloppy cutting job. buy a round instrument if you can, and just use a freaking hole saw. It's so much easier. All right, new bezel, hot off the printer. Let's go test fit it. All right, moment of truth. Fits like a glove. Look at that. Drop it in the dash. I still have to screw it in from the back, but now we've covered up all those gel coat blemishes. That looks way more presentable. I'm into it. Never fails. Every time we break out the camera, the neighbor breaks out the leaf blower. All right, let's just finish this project up. This is taking way longer than I was expecting. Next up, we're gonna mount this little shunt resistor sampler thing. I'm just gonna stick it probably up here on this panel. And then all we have to do is run this red wire to a positive terminal, straight to a positive bus bar here. And then we've got to run our negative from our new house battery cable to this input terminal, and then jump over the other side of the negative from this terminal back over to our negative bus terminal. So it's just, this shunt resistor just goes in series between the negative cable of the house power supply. So let's knock this out. Guys, I'm losing steam here. We just pulled the drill bit out of the drill. Come on, this is nuts. Nothing's ever easy. Ugh. All right, we've got this thing wired up, our little sampler unit here. All right, guys, so we have the project all finished up here. This is what the finished product looks like. And so we've got voltage display up here and current display here. And you can see that printed bezel really filled that in nicely. So that's looking way more finished. I'm pretty pleased with that. Covered up that hack job from earlier. So now I'm going to run through some of the accessories and see what kind of loads we're measuring on the amp meter. One more thing I wanted to show off. We removed that kind of temperature sensor that was sitting here, replaced it with this battery monitor. I did go ahead and replace that temperature sensor because I thought that was a cool feature. With this one I got off of Amazon. And so it reads inside cabin temperature, and there's also a sensor I have placed back in the battery compartment sort of outside that reads external temperature. And so when we're out at night running the diesel heater, we get to see what the outside temp is and the inside temp, which is kind of cool. Next up, let's try out the diesel heater. So I've got this kind of master switch to arm the diesel heater. So I'm going to go ahead and unplug my USB charger just to kind of get back to our baseline kind of 100 milliamp current pool. And when I turn on the cabin heat, that fires up the thermostat over here. And that draws, I don't know, maybe 100 milliamps, so not bad. But now the moment of truth is, let's fire up the diesel heater. Hit this button here. Start heating. And that's going to, like it said, start heating. And so we can watch the current draw climb. Now I think I read this pulls about 15 amps maybe during warm-up. So when the diesel heater is warming up, it's got a glow plug it has to run. There's a fan it has to run. And so it pulls, and then there's a fuel pump too. So it pulls the most current during warm-up when it's running that glow plug. All right, so we're getting pretty far along into the warm-up of the diesel heater. You might be able to hear the fuel pump back there clicking. And I can hear the fan running on the heater. And so far, the peak load I've seen was about 10 amps, where it's sitting at about 9.4. You can hear the heater throttling up. And so, like I said, so far for warm-up, which is when this thing is supposed to pull the most power, I haven't really seen it go above 10 amps. There's 11. And something just happened. I heard that the speed... Okay, so our amperage just dropped significantly, so I bet that's the glow plug turning off. And so now it's just running fuel pump and the fan inside the heater. So now we're running way less current. All right, this is pretty cool. So we have the heater. It is warmed up and it's on its lowest power setting. So you can see here, that's that just kind of 1 bar of power. For reference, I was out, I stayed the night in the boat a couple weekends ago, and it was like 47 degrees outside. And when I had this on the lowest power setting, it kept the inside of the boat at about, it was like 74 degrees. It was really warm in here. This is the 5 kilowatt diesel heater version, by the way. So 5 kilowatts, I guess is what I'm saying, is plenty of power for a boat this size. But we're at kind of steady state, low power heat mode, and we're pulling about an amp, which is insane. So that's like nothing. At an amp, we could run this with the batteries we have on the boat for like 170 hours. So you'd run out of fuel way before we ran out of electrical power. So next I'm going to fire the diesel heater up to its highest power setting and see how much current we pulled in. All right, that's full throttle. Let's see what she does. All right, so we're wide open throttle on this diesel heater, full blast, and we are pulling about 3.5 amps, 3.6 amps, which is like nothing. That's awesome. And so for reference, in the back of the boat here, we've got 2 140 amp hour batteries. So was it 280 amp hours of total reserve capacity? So if we're pulling 4 amps, that's like 70 hours of runtime for this heater of full blast. So I'm never going to run this heater for that long, especially without running the motor in between. I just need it to last the night. So 70 hours capacity is going to be plenty for me. Not to mention, you're probably going to run out of fuel before you hit 70 hours of runtime on this heater. So pretty stoked with how that works. I'm going to go ahead and shut it down now. But good to know how much power we're pulling. And now with this current monitor, we're able to always monitor not only our battery voltage and capacity, but how much power we're drawing, just so we have some peace of mind when we're out there on anchor, camped out overnight. All right, guys, so now that we checked out current consumption on the diesel heater, I wanted to run through a couple other accessories just to give everyone an idea of what they can expect. Various accessories to pull on the boat if they decide to run them overnight, let's say, on anchor. So one of the big ones that I've actually heard some discussion about on a Facebook group recently was the amount of power that your chart plotter pulls. So I've got this Garmin multifunction display here. It's got GPS, and I've got the sonar fish finder thing running. So one of the things I like to do with this is use it to set up an anchor alarm. So I can set a certain radius around my anchor spot, and if the boat drags, if we drag anchor overnight, it'll start beeping, wake you up, and let you know that you need to check your anchor. And so a lot of people like to run those overnight, and I just wanted to give you an idea what kind of current consumption we're expecting here. And so with only the Garmin running, it's the only accessory I've got on right now, we're pulling about, let's call it 700 milliamps or 0.7 amps. So that's pretty good. That's very little current draw. So you can easily run an anchor alarm overnight, assuming you've got a, even decent battery setup. One more thing I wanted to monitor. Let's check out VHF radio. So I just kicked that on, and that is pulling about 150 milliamps. So super negligible. So leaving your VHF on all night, probably just fine. Again, this is all for my boat. Your boat may be different, but just kind of giving you some general numbers to reference when you're camped out. All right, so like most projects, that took a lot longer than I was expecting. That really ran into a couple unexpected hurdles. 3D printer came to the rescue, and at the end of the day, I'm really happy with the install of this thing. This is really going to give us peace of mind when we're camped out on anchor, just to know that we'll have enough battery left over to crank the motor in the morning. Side note, I usually do, with this new battery switch, I usually do switch over to running all the house accessories off of one single battery. So that way, if I did happen to run the battery down overnight, we still have a second battery to kick the motor off of from. And I know with one of those 140 amp hour batteries and the pretty minor loads we have on this boat, that's not going to be an issue.
So want to thank everybody for tuning in. If you haven't done so, if you like the video, please consider clicking that like button down below and subscribing to the channel. I'm looking forward to making more videos like this, both on kind of DIY how-to stuff and also documenting some of the Sea Dory adventures that we have coming up here in the future. So please consider subscribing and look forward to making more videos for you guys in the future. So stay tuned and thanks for tuning in.